Hello everyone, welcome to another video. In today's video, I will be talking about Docker Compose. So what is Docker Compose? It is a tool or a utility in Docker that is used to deploy multi-container based applications. Now, what is the meaning of multi-container based applications? To explain this, I have two diagrams. Okay, so let me open diagram number 1. So this diagram relates to what we have already learned in my past videos. Okay, so in my past videos, I have a virtual machine on which I have installed Docker, which means that it becomes my Docker host. Okay, now suppose I'm using Apache Docker image to create this container here. Okay, so I know that Apache web server runs on port 80 by default. So when you create a container out of Apache web server image, Apache Docker image, it's going to run on port 80 by default. Now to access this application running on port 80 from my Docker host, I will use port mapping. Okay, so in this example, you can see what I have done is I'm using port 80 on my Docker host to access this container application, which is also running on port 80 inside the container. So as an end user, when I access the IP address of my Docker host and port 80, it's going to forward the traffic to port 80 inside the container. So I can access this application on my web browser like this, right? So this is what we have learned so far. So in this example, if you see, I only have this one single Docker image, which was used to create one single Docker container. Okay, and this is my entire application. So these type of applications are called single tiered application, which means that there's only one layer which is available in this application. In our case, it is the web server front end, right? But in real world, what will happen? You will have multi-tiered applications, which means that you will have to create multiple containers as part of single application stack. So to deploy those type of applications, you can use Docker Compose. Okay, so the difference is when you run the standard Docker and commands. So these Docker and commands are generally used to create a single container based applications, as it is in this example. Okay, but when you have these multi-tiered applications, which means that you have like this front end, you also have a backend, and you also have a database. Okay, so this is the example of a multi-container based application in diagram number 2. Okay, so if you have this type of application wherein there are multiple layers of your single application stack, so these applications are deployed using Docker Compose. Okay, so now you know the difference between a single tiered application and a multi-tiered application. Okay, so let's just understand what a multi-container based application actually comprises, or we can say what are the prerequisites or the things or the resources that a multi-container based application would need. Okay, so in this example, as you can see, I have a front end. So you can take this as Apache, for example. If you see in this example, I'm using this container application here. So just assume that this front end is the same web server container which is based out of Apache. Okay, so it is our front end part of the application, or you can say it is the front end tier of the application. Okay, then but in this example, we also have two other tiers of the same application. So we also have a backend, which is like the layer where your main application logic resides. Okay, so this is your backend. Then you also have a database layer in this application. So whatever data is being generated by your application is going to be written to your database. Okay, so so if you see here, once again we have three different Docker containers that we have to create as part of this single application stack. Okay, and also we have to include the ports. So in this case, if you see, this front end is being accessed on port 8080 by the end users. Okay, also if you see this database, so if I talk about one example of a database in Docker, like Postgres. Okay, so each Postgres database, it needs at least one environment variable, which is for the password. Okay, so this database is also going to use some environment variables also to function properly. Okay, then what we want the connectivity between these three Docker containers as well. For example, we want this front-end Docker container to be able to talk to our backend, okay, on a network. So here I'm using this network one. Also, we would want our backend to talk to our database on another network. So I have taken it as this network 2. Also, I want to have the persistence of the data in these two containers, especially our database. Okay, because if you're using database, which means that you need this data even if the container is terminated or crashed. Okay, so you want that data persistence also in these type of Docker containers. So you would want a persistent volume, right? So similarly for this backend Docker container, I also want persistent volume. So if you see here, this entire application stack, it needs a lot of things to function properly, right? You need these port mappings, you need these networks, you need the three Docker images to be configured, you also need the volumes to be configured. Okay, and you also need environment variables as part of your database. So if you see here, to deploy this type of application which has so many things in it, what we use Docker Compose. So how we use it? What we do, we write the entire configuration into a single file. It's called compose file. So this entire configuration can be written to a YAML file, YAML compose file. Now what is YAML? YAML stands for yet another markup language. So this YAML is used almost everywhere in the world of DevOps. It is used with Docker Compose, it is used with Ansible, it is used with Kubernetes, okay, and some other tools as well. So it is like the most important language in the world of DevOps to write the configuration files. Okay, so in this example, I'm taking this example of 3-tier application. So I want to write this in a configuration file. So for that, I will be using a YAML based compose file. So this is the concept of Docker Compose. So what do? You write all this configuration from the diagram into a file. Okay, and then you use that file as the base to deploy your application. Okay, now why do we want to do that? So there are some benefits of using this approach to deploy a multi-tiered application. Okay, so if I want to explain that, so here I have listed out a few benefits of Docker Compose. So let's go through these one by one to understand them conceptually. First one is no need of manual Docker and commands. Now if I go back to my second diagram, so here just imagine that we do not have a tool like Docker Compose and we just need to deploy this application. So the only other way is to use Docker run commands. So for this type of application, if we try to do that, if we try to deploy the application without Docker Compose, in that case, we would be running these Docker run commands, one for each of these containers. We also have to make sure that we are specifying the right port mappings, the network configuration, or and all the information related to our volume. So all that has to be done manually using these Docker run commands. But this is not a very efficient way of doing it, okay, because you have to run these commands one after the other, right? So in this way, if we use Docker Compose, it is more efficient, okay, and it is more simple also, because we just need to create this file once, and when we use the Docker Compose commands like Docker Compose up command to deploy our application in one go, so it is actually more efficient and easier to do, right? So no need to run all these manual Docker and commands to create these containers individually. Okay, this is one of the benefit. Now, how this is going to help us? The application will have consistent behavior. How? Because suppose this is your application, you wrote this configuration file compose.yaml. Now, if you just push this file to repository like GitHub or GitLab, so whosoever wants to deploy this application on their machine or in their own environment, they just need to ensure that they have Docker and Docker Compose installed on their machine, and then they can just download this particular compose.yml file on their machines from a repository like GitHub or GitLab, as I just mentioned, and they just need to use the same command that the other person who created this file used, okay, which is docker compose up command. What it's going to ensure is the behavior of the application is going to be absolutely same whosoever is running it, because all the configuration is once again inside a single file. So whosoever has access to that file will have the same behavior of the application as well, right? So in this way, the application's behavior is going to be consistent across all the environments, all the different machines, okay, no matter whosoever is running it. Then point number 3 is automatic network creation for all services to communicate. I am taking an example where I want to have 2 different networks for 2 different use case. For example, this frontend should be able to talk to backend only on network 1, and this backend should be able to talk to database on network 2. But if you don't specify any network configuration in your compose.yml file, in that case, compose is going to create a default network, okay, and that network will be used by all of these containers to communicate with each other. So this is the default behavior of the compose.yml file. So in this case, if you see, I do not have to specify a network. If I don't have a specific requirement of having separate networks for my different use cases, in that case also it's going to work, okay, because all these 3 containers will be able to communicate with each other using the default compose network, okay. Then handles dependencies automatically. So let's go back to our diagram. So in this example, if you see, we want this front end to talk to backend, okay, and the backend should talk to database. Now, handles dependencies automatically means that in compose file, we have the option to specify in what order these containers should be created, because we want our database to be created first, then our backend, and then our front end, because there may be a case if front end is created first and if it is trying to talk to our database which is still not created, in that case it can result in some failure or some error of the application. So we have the option of defining this dependency in our compose file using a depends on a parameter that we can use to so for example, in this case what we can define is, we can define that this backend Docker container, it depends on database, which means that this database container should be created first and then our backend. And similarly, if I talk about this front end to a backend communication, this front end is dependent on our backend, which means that this backend should be created before front end. So in this way, we can specify in what order this container should be created, so it is able to handle all the dependencies as well for us. Easier to scale. So with Compose, we have the option of scaling up our application. For example, we can define how many instances of this application we want to deploy. So we can use this scale flag with our Docker Compose up command. So Docker Compose up command can be used with an additional flag of scale, which is going to specify how many replicas of our application do we want to have. Okay, so it is easier to scale as well when we use the Docker Compose to deploy our applications. So here is the theory of Docker Compose that we just spoke about. So it's a tool for defining and running multi-container applications. It simplifies the control of your entire application stack, making it easy to manage services, networks, volumes, and environment variables in a single comprehensible YAML configuration file. Also, I would like to mention that Compose can be used in all the environments, whether it is production, staging, development, testing, as well as CI workflows. Traditionally, it was only used by developers to do some local development of their application or local testing of their application on their development machines. But now Docker Compose has a version, or we can say has a particular type of configuration that can be used in production too. Okay. Now let's understand how Docker Compose actually works. Okay, so we just spoke about that we have to write this YAML configuration file, but how to write that file? So as I mentioned earlier, that it's going to be a single file only, a single YAML file. YAML stands for, okay, it is sometimes called YAML in markup language, or sometimes it is called yet another markup language. Okay, so it's a single file that you're going to use. It's called it will be called compose.yaml by default. So this is the default file name that you can use with the latest version of Docker Compose. So this Docker Compose has a lot of versions, but if I talk about the latest version of it, okay, as I'm talking in this video, the default name of the file that is accepted when you run this Docker Compose commands, it's going to be compose.yml. And this file is going to comprise of your Docker containers, which are called services, your networks, your volumes, and your environment variables also. Okay, and some of the key commands, if I talk about, to start all the services defined in your compose.yml file, you just run this single command called docker compose up. It's going to create everything in one go. It's going to create the containers, it's going to create the networking, it's going to create the volumes for you. So it is going to make your application absolutely ready, okay, for the end users to access by using this one command only. And when you want to stop and remove these running services or these containers or your entire application, you can use docker compose down command. It's going to stop and remove all your running services. Okay, now if you want to monitor the output of your running containers and debug any issues, you can use docker compose logs command. And to list the services running as part of your application stack with Docker Compose, you can use Docker Compose PS command. So if you can see here, the commands are quite similar to the standard Docker commands like Docker run, Docker logs, or Docker PS. So in this way, you have Docker Compose also. Okay. So this is the structure of the compose file that we are going to create to deploy our multi-tiered application. So let's see how we can install Docker Compose on an Ubuntu 24.04 LTS machine. So this is the URL where you can find all the steps, and I'm going to give it to you in the PPT that will be there for this video. Okay, so here you can see the first step is to download and install the Docker Compose standalone. So just copy and paste this from here and just paste it and enter. So it's going to download the package and install it as well. Next is apply the executable permissions to the standalone binary. So just once again, you have the ready-made command that you can run. Next, so you can just use this command to test the installation. So you can see you get the option to see different options with Docker Compose commands, which means that Docker Compose has been successfully installed. Okay. So let's do some hands-on practice on Docker Compose. So to do that, Docker has given us some sample projects that we can use to do all the practice and get comfortable with Docker Compose. And this is the URL of their GitHub repository. It is given by Docker themselves. So you can copy and paste this in your browser to check all the details, or if you just go to Google and type Docker Compose samples, you will see this result at the very top. So you can open it from here also. So this is the GitHub repository. It looks like this, and within this you will see these different projects or different samples of Docker Compose that you can practice. And I think this is just good enough to make you comfortable with Docker Compose. Okay, and under README information you can see all the different details that are related to this particular repository. Okay, so all the things are given here. So it's a very good repository if you want to practice Docker Compose projects. Okay, so within this project I have chosen one, which is this one. So I'm going to do this Nextcloud Redis MariaDB project right now to give you a demo of how Docker Compose works, and I'm going to explain the details of this compose file as well, which is given as part of the project. So first things first, I'm using an AWS EC2 instance based out of Ubuntu 24.04 LTS machine, and I have Git installed already. So I can use Git to clone the repository, the GitHub repository. Okay, so just go here, click on code, copy this HTTPS URL from here, and do git clone. Then repository name, hit enter, done. Then I'm going to cd into this, and then if I do ls, I can see all the different projects, and I'm looking for Nextcloud Redis MariaDB project. Done. And if I do ls, I will find all the project files. So the file that we are looking for is compose.yaml. So as I mentioned earlier, when you create your compose.yaml file, if you keep the name as this one, then you do not need to specify any additional flags or additional arguments to your command when you are running Docker Compose commands, because this is the default name that this Docker Compose file expects. Okay, so whenever you are using Docker Compose commands, if you don't specify any additional flag to identify the file, then it's going to look for a file with this name as it is, compose.yml. So try to keep the file name exactly same as this one. Okay, so let me just open this file and give you some information of compose.yml file. So it is in YAML format. I'm going to try to come up with a video on YAML basics as well, so that you understand how YAML is written. Okay, but for this video I'll give you some information into this. So here under services we have 3 containers defined: NC, Redis and DB. How YAML works: in YAML, indentation is pretty important. So as you can see, under services we are defining these things after some indentation, so which means that this and this are part of this services. If I talk about NC, Docker container, whatever is inside NC, it's all part of NC only. Like from image, starting from image till here, it's all part of NC, because we're defining these different properties of NC under NC. So this is how YAML works on a very high level. But of course, I will try to make a video where I will cover all the basics of YAML, or how to write a YAML file from scratch. Okay, but for now, just understand that whatever you see like this. So starting from services, under services you have these 3 containers, and also you can see that these 3 are on the same level. As you can see, NC, Redis and DB. So all these 3 are different elements of the same services section here. Okay, then in NC you have all these parameters, and similarly for Redis and DB you have the same. Okay, so this is about YAML part. Now let's come back to our Docker Compose concepts. So here you are defining the name of the container. Now how do you want to create the container? So just like you run the docker run command, okay, docker run, then name of the container, then you do port mapping, volumes, and then you specify the name of the image at the end. So all those options of your Docker run command will be coming up here in this section, because this particular section is like one single Docker run command. Okay, so all that you mention in a Docker run command can be mentioned here inside the Docker compose file, like what image you want to use. Now this image, it's mentioned here, which means that this image should be available either on your local machine or it should be available on your Docker registry. Okay, so here we are still using the default Docker registry, that is hub.docker.com. So this image should be available there. Okay, so let me go to hub.docker.com. Okay, I'm here already, and here's the name of the image. Okay, so when you go to this page, if you search for this image Nextcloud, which is what we are using inside of our compose file, Nextcloud, and Apache is the tag that we're using. Okay, so if you go here, search for this image here, and if you go to tags, you can search for the tag that you are using, so that you know that this tag actually exists and it's not going to fail. So if I just type Apache here, this is the Apache tag that we are trying to use here. Okay, also if you want to understand about these environment variables that I mentioned, so let's go step by step only. So image, we know that this image is already there on our Docker Hub. Okay, so we can use it here under this image section. We are also using Docker's restart policy. So we have various options for specifying how Docker container is going to behave depending on its different statuses. So here we are using the restart policy of always. Okay, so I mean, I haven't covered this section is, but just to understand this, we want this container to be running at all times. So that is why we have set this restart policy to always, which means that whenever the container stops, it's going to restart itself automatically. Okay, then we have this port mapping. So when you run the Docker run command, you use -p for publishing ports. So it's the same thing here. So here I'm using this host port is 80 and port inside the container is also 80. Then I'm also using a volume. So I'm using this nc_data volume, and I'm mounting this volume or mapping this volume to /var/www/html inside the container. Then I'm also attaching this container nc to two networks, redisnet and dbnet. Okay, and then I'm using some environment variables, redis_host, mysql_host, and so on. So how do you know that these environment variables are required for this particular image? So all that information is available on hub.docker.com. Okay, so let me go back here, and if you just go to overview section again of this image, and if you just scroll down, just read through this information, you will find all the relevant details that you need to create the container from this Docker image. Okay, so here if you just scroll a little bit further, you will find all the information related to environment variables also. So environment variables are there, volumes is there. Okay, everything is already given on this image. So this is where we go to find all this information whenever we want to use this in a compose file, what environment variables are required, and where to mount the volumes, which port does it work. So all this information related to a particular image is available on hub.docker.com. Okay, so if you just scroll down, you will find these different environment variables that I used here. Okay, so all this is part of this hub.docker.com documentation of this image, where we can find all the information related to different environment variables that we need to use along with this Docker image. Okay, so environment variable is nothing, it's just a way to pass some dynamic information for your container. Okay, so if you if you want to change it, you can do so. So these are just the some specific type of dynamic values that you provide to your container at runtime. Okay, so those are called environment variables. Then similarly for Redis, you have image section, which means this image should either be available on your local machine or it should be available on your Docker registry. Okay, then I'm again using this restart policy, so this container is going to keep on running. Okay, so whenever it stops, it's going to start itself automatically. Then I'm also using this networks called RedisNet, and I'm exposing it on 6379. Okay, so expose is another property where you can expose this service on a port. So I'm using 6379. So inside of this container, Redis works on 6379. So this is the default port of Redis. Okay, and similarly for DB, it's the same thing. So once again, you have all these options available on hub.docker.com, how to use this image to create a container. Okay, so all this is available on your Docker registry, so you can go through it to understand each of these options. Okay, so this is how this services work, and yep, so that's all I wanted to cover as part of this particular compose.yml file. Okay, and let's just come out of it now. So now we have our compose file, we have it ready. Okay, so we just need to do a docker compose up command. Also, if you're getting stuck somewhere, you can go to this Docker Hub registry, and you can check for your projects, and you can go to this readme.md file to understand everything that you need. Okay, so this is the compose.yml file, and here you can see how to use it to create your application stack. So this is the command that you have to use. Okay, so you can do this docker compose up command. I'm using -d here as it is given here to run this in a detached mode. So here I'm using the standard command with -d for detached mode, which means I'm going to get my terminal back. So here, as you can see, I'm using the default file name, so I do not have to specify any additional flags to make this command find the files. Okay, so it's going to look for compose.yml file in this directory where I'm running this command. Okay, so just run this command in the same directory where you have compose.yml file. After I do this, it's going to start pulling the image. Okay, the 3 images from Docker registry, because I don't have this image locally on my machine right now. So it's going to pull the image, and then it's going to create the container with all the options that we specified in our compose.yml file. It's done. So you can see the images were pulled, and the containers were created as well. Okay, so let's see what all this command did for us. So as you can see, we just ran this one command, and it has done multiple things for us. Okay, so how easy it is to create an application which is multi-tiered using Docker Compose. So Docker images, you can see we have 3 images. Okay, so these are the 3 images that were built, and if I do Docker PS, you can see the 3 containers as well. Okay, which are running. Okay, also if I do Docker volumes, let's see, Docker volume ls. So you can see some additional volumes also created. Okay, here. Right, so this is what a single command can do for us. Okay, if I do Docker network ls, so you can see some additional networks were also created. So we just ran this one command, and it has done a lot of things for us, right? So this is how simple it is to use Docker Compose. Now let's go back to the project's documentation here. So expected result is this, which is fine. And so to access the main application, your front end part of the application, you have to go to a browser, and you have to use the IP address of your machine on which you are running, on which you are using Docker Compose, and just use this port 80. If you don't use anything, if you just use the IP address of that machine, it's going to take port 80 by default. Okay, so this is the way you can access the application. So let's try to access it from the CLI first. So I'm going to do curl localhost. Okay, if I don't specify 80, it's going to be 80 anyways. Okay, so either you can access the application like this, or you can use localhost. So it is the default port. So okay, so looking at this output here, it means that the application is running fine. Okay, else you would have seen some error messages. Okay, so seeing this output means that the application is up and running and we are able to access it. Now let's try to access it from the browser. Okay, so this is the IP address of my machine on which I'm using Docker Compose here. So just refresh. Okay, so as you can see, I'm able to access the application, and this is the application that we were that we wanted to see. Okay, so you can check it here also. This is the expected application. Okay, now if you have to remove the containers, just do Docker Compose down. Let me clear the screen, and if you do Docker Compose down, one more thing. To delete all data, remove all named volume by passing -v argument. So if you want to get rid of the volumes as well, then you can add -v option as well. So once again, this one command is going to do a lot of work for us. Okay, so it's going to remove the container and the volume and the networks. Okay, so this is how simple it is to stand up an application or stand down an application using Docker Compose, for especially for multi-tiered application. Okay, so that's all I wanted to cover in this video, to give you the conceptual knowledge about Docker Compose. I mean, what are its benefits, why we want to use it, and how efficient it is to use it for a multi-tiered application or a multi-microservices based application. There are various projects. Okay, so it's a long list, so you can see what all you want to do. So I think this is just, I mean, good enough to make you understand almost all the things for Docker Compose utility in Docker. Okay, so I hope you liked the video. If you did, please hit the like button, please share it with your friends, and please do subscribe to my channel. Alright guys, that's all for this one, and I'm going to see you in the next one.